Now we're going to briefly touch on soil chemistry, which sounds like something you should do for the Bionutrient Food Association. But I don't want anyone to get confused because we're talking about numbers. Numbers seem really powerful and scientific, and like we've got to do the number thing. The biology trumps soil chemistry over and over. And yet, there's things to be learned by what's taking place here. So, nutrition, better plant metabolism, more disease resistance. Spotted winged Drosophila is not as interested in that plant. So we do soil testing. Different labs do different methods, and the interpretations of those methods fall into one of two camps. One is all about maximizing yields, so you make more income. And that sounds good, but it's not necessarily as balanced as growing healthy plants that have resistance to disease, so you get a decent yield that you don't have to medicate as heavily. And so that second camp, based on base saturation ratios, is really what's known as the Albrecht method. And Dr. Albrecht was a soil scientist at the University of Missouri, and he developed these different fertility ratios. So I'm presenting that point of view when I look at a soil test, talk about it. So, the pH thing, we're going to examine from another perspective, but basically the acidity scale is about nutrients being available to the plant. I do more with this on the front end when I'm prepping soil than I do further down the road when the trees are bearing. We'll explain that. Organic matter, that's what's driving the biology. So ramial wood chips and orchard compost over the years, that's going to start to go up. Phosphorus, in that listing of amendments in the soil tree hole, I include some either black rock phosphate or colloidal phosphate. Not too much, but I'm just putting pockets here and there that solubilizing bacteria are going to break down and make available to the fungi. But I also don't want to put a flood of soluble phosphorus in there. But this is all about getting that fungal ecosystem up and running. So I can make a little chart and make a little note, here's the soil amendments. But again, there's a story to be told at each one. So that's kind of a big picture perspective of what I look at, what I think about. But it really begins with knowing the nature of calcium and magnesium in your soil. And these are the cations that are evaluated to show you what your pH is. So pH is just kind of a gauge. It's not the real story. And when I look at a soil test, first I look at the cation exchange capacity number, the CEC number, because when it's a really low cation exchange capability, we're talking about a nutrient porous soil, basically a sandy soil. I don't even need a soil test to kind of know what a sandy soil looks like. But I know that calcium, let me get this right. I can read my own slides and get it right. I know that magnesium helps to bind soil particles together. So if I see a low CEC number, I'm going to want more magnesium than I'm going to want in a heavy clay soil with a CEC number that is like 18, 20 or higher. And if I'm not there to see a soil and feel it, the CEC number kind of tells me. In a clay soil, I want more calcium because it helps spread that soil apart. So I can utilize my choice of lime to help the soil structure. I know that in the long run, it's the biology, the mycorrhizal fungi making soil aggregates that's really going to create the right soil structure. But I want to go into this science thing, this pH thing, with an awareness of this choice between calcium and magnesium. The other thing I look at is how many pounds per acre of calcium are there. I want to start at the right baseline if I'm talking about a fertility ratio. And there I'm looking for at least 2,000 pounds to get going. So if you have a low pH soil and you get a recommendation for a couple tons of lime, the soil scientist is accounting these different factors in that picture. I want the relationship between calcium and magnesium to be 7-to-1. So that's the right balance point for a nice loam. and this particular slide, I designed handouts to give you the numbers in your handout. I did that one, I think. Yes. One of the set of numbers on a good soil test that's useful are the base saturation ratios. So there you see a percentage for calcium to magnesium to potassium. And that's what these three numbers are referring to. So 70 to 10 for that nice loam, you're getting that 7-to-1 ratio. With the sandy soil, I up the magnesium number because of the structural efficiency of that sand in terms of holding nutrients. And with a heavy clay soil, we're going to up the calcium number, and that's going to shift the other numbers. And that's in your handout. In the incorporation phase, if I'm prepping soil for planting a fruit tree orchard or berry patch, and I'm going to till the soil as a way of breaking up compaction, and I'm going to have an opportunity to incorporate the lime deeper, that's when you're going to do that 1 ton per acre. Sometimes you'll see a recommendation for much more than that. I tend not to go quite as heavy on that, but I also know that lime, the effectiveness works way down into the soil at 1 inch per year. So I want to take advantage of that moment, because I'm not going to till, incorporate once I have the trees in place. On the other hand, once I'm getting the biology up and running, I also don't want to flood it with lime and just wump it. What I want to do then is use a maintenance rate. And that's going to be on the order of 400, 500, 600 pounds, just because acid rain shifts things and you might need to affect the pH. That's something I apply in the fall, when about 1/3 of the leaves have come off the tree, because it actually has an impact on the ability of the scab disease to reproduce itself. So that all ties into what I call stirring the biological stew in fall. But I'll take advantage of the fact that, well, since I need some more lime now, 4 years have passed, my pH is dropping, I'm going to utilize it in that fashion. Calcium is really important. Another material is gypsum, calcium sulfate. And gypsum can be used to add calcium without affecting the pH. So this is something I use as a soil amendment in early spring, particularly for trees that seem more calcium stressed. So if you're growing honeycrisp, by definition, honeycrisp is calcium stressed. There's something called honeycrisp yellows, which is a result of that tree struggling to take up calcium. But if I have heavy cropping trees and I've removed a fair amount of calcium in the form of fruit, I will also add gypsum there. The sulfur component of gypsum contributes to the ability of the tree to synthesize proteins better. So again, I'm throwing many things at you, and a few of these are bits that 1 or 2 you need, and you're hearing it. Others, you're going to recognize, oh, I have honeycrisp with those yellows. I need more calcium. I'm doing it in early spring because it precedes the spring feeder root flush, because that's when I want to get it in there for what's coming in summer. Phosphate. I used to do more with this. And I mentioned rock phosphate in the planting hole. In eco-ag, people recognize that produce with higher bricks grows in soils where the relationship between phosphorus and potassium is on the order of 2 to 1. In orchards with those ramial wood chips, we're adding a lot of organic matter, and that means a lot of potassium. So if the soil is low in phosphorus, I play with this number a little bit. I don't do too much because I know that mycorrhizal fungi are going to come in and pick that up. Now, this is for the Yankees in us. When you approach soil amendment, when you think in terms of acres, it can add up to be quite a lot in terms of the price. I have this notion of the expanding tree radius. So when I plant a tree, and I talk about soil amendments in the planting hole, I may be covering a 4 or 5, even 6 foot circle. Not just where I dig, but in the zone where the feeder roots are going to reach in those first several years of growth. And I start to build that fungal soil ecosystem. I then come in, maybe in year 3, 4, or 5, and I might do some more soil amendments further out, because now the tree's reaching out into there. But at that point, the biology is also kicking in. So from the perspective of like thinking, I need sulfate of potash, I'm really low in potassium early on. I'm not doing the whole acre. The math works out that I'm actually doing about 15% of the acre. So as a tree person, you can kind of grow into your nutrition zone as you can afford it. That's that concept.